Page 128. Exponentiation. Meaning of exponentiation. If a is any real number and n is positive integer, then a to the power of n equals a times a times a times a times a. We call a to the power of n an exponentiation. A is base and n is exponent. Properties of exponentiation. If a, b are any real number which are not zero and m, n are positive integer, then page 131. N, the root of real numbers. Definition. Let a and x be real numbers and n is integer greater than 1. X is n root of a if and only if x to the n power equals a. If x to the power of n equals a, then x is n root of a and can be written as x equals n root of a or n root of a equals x. For example, 2 to the power of 3 equals 8, then 2 is third root of 8 and can be written as 2 equals the third root of 8. 5 to the power of 4 equals 625, then 5 is fourth root of 625 and can be written as 5 equals the fourth root of 625. Page 132. The n root of a, read as n the root or a or n the radical of a, n called order or index of surd. In case of n equals 2, we use the square root of instead of the second root. From definition, n the root of a is number which raises to n power and equal to a. In this case, the n root of a has the following meanings. 1. If a is less than 0, then the n root of a means positive n the root of a. Example, square root of 4 equals 2 because 2 to the second power equals 4. The third root of 27 equals 3 because 3 to the third power equals 27. 2. If a is less than 0 and n is odd number, then the n root of a means negative n the root of a. Example, the third root of negative 27 equals negative 3 because negative 3 to the third power equals minus 27. 3. If a is less than 0 and n is even number, then the n root of a is not real number. Example, the fourth root of negative 16 is not a real number because there is no real number that raises to power of 4 and equal to negative 16, or because 2 to the fourth power equals 16 and negative 2 to the fourth power equals 16. 4. If a equals 0, there is only one real number which is 0, or if a equals 0, then the n root of a equals 0. Notice 1. Symbol, the n root called radical sign, n called order or index of radical. 2. When a is real number, we call any real number in form of the n root of a. Examples of radical are square root of 2, the fourth root of 8, and the third root of negative 27. 3. The n root called n the root of a or principal n the root of a. Page 133. Properties of n the root. When m and n are positive numbers greater than 1, a and b is real numbers, whereas the n root of a and the n root of b have real values. 1. The n root of a times the n root of b equals the n root of ab. Example, the square root of 2 times the square root of 3 equals the square root of 2 times 3 equals the square root of 6. 2. The n root of a over the n root of b equals the n root of a over b. b does not equal 0. Example, the third root of 6 over the third root of 7 equals the square root of 6 over 7. 3. The m root of the n root of a equals the mn root of a. Example, the fifth root of the third root of 3 equals the 15th root of 3. 4. The n root of a to the n power equals absolute a when n is an even number, equals a when n is an odd number. Example, the fourth root of minus 2 to the fourth power equals absolute minus 2 equals 2. The seventh root of minus 2 to the seventh power equals minus 2. Notice, the n root of a is real number when 1. A is real number which equal or greater than 0. A is equal to or greater than 0. Or 2. A is less than 0 and n is odd number. So, if we want the n root of a to be real number without regarding n value, we have to define a greater than 0 for all case. Page 134. Exponentiation with rational number as exponent. Definition. Let a be real number and n is positive integer greater than 1. If the n root of a is real number, then a to the power of 1 over n equals the n root of a. A is greater than or equal to 0 when n is even positive integer, and a is real number when n is odd positive number. For example, 5 to the 1/3 power equals the third root of 5. Properties of exponentiation. Let m, n be rational numbers, and a to the m power, a to the n power, b to the n power are real numbers. We get 1. A to the m power times a to the n power equals a to the m plus n power. 2. A to the m power to the n power equals a to the mn power. 3. ab to the n power equals a to the n power times b to the n power. Definition. Let a be real number and mn is positive integer greater than 1. If the n root of a is real number, then a to the power of m over n equals a to the power of 1 over n times m equals the n root of a to the power of m. A does not equal 0 and m does not equal 0 because 0 to the power of 0 is not defined. Or a to the m power over n equals a to the m power times 1 over n equals the n root of a to the m power. For example, 8 to the power of 2 over 3 equals 8 to the power of 1 over 3 times 2 equals third root of 8 to the power of 2 equals 2 to the power of 2 equals 4. Or 8 to the power of 2 over 3 equals 8 to the second power times 1 over 3 equals the third root of 64 equals 4. 4. A over b to the power of n equals a to the power of n over b to the power of n. b does not equal 0. Page 135. 5. When a does not equal 0, a to the power of n over a to the power of n equals a to the power of m minus n, where m is greater than n. 1 where m equals n, or 1 over a to the power of n minus m, where n is greater than m. 6. A to the power of negative n equals 1 over a power of n. 7. A to the power of 0 equals 1. 8. A to the power of m over n equals a to the power of 1 over n times m equals a to the power of m to the power of 1 over n. Or a to the power of m over n equals the n root of a to the power of m, when a is positive real number or n is greater than 0. Page 136. Solving exponential equations. Exponential equations are equations with integer or fraction as bases and variables as exponents, or equations with variables as base and integer or fractions as exponents. Solution procedures are as follows. 1. Equations with integer or fraction as bases and variable as exponents are called exponential equations. For example, 5 to the power of x equals 125. 4 to the negative power of x equals 1 over 64. To solve this kind of equations, we have to equalize bases of equation, then solve for variables. That is, if a to the power of x equals a to the power of y, then x equals y. 2. Equations with variables as bases and fractions as exponents can be solved by separating variables and constants on the opposite side. Then raise both sides to the power of reciprocal exponent and solve the equation. Page 139. Application of exponentiation in actual works. Power of 10. Large numbers can be written in form of power of 10 as 10 equals 10 to the first power,
100,000 equals 10 to the 5th power. Small numbers can be written in form of power of 10 as 0.1 equals 1 over 10 equals 10 to the negative 1 power. 0.0001 equals 1 over 10,000 equals 10 to the negative 4 power. Numbers can be written in form of a times 10 to the n. 1 is less than or equal to a, less than 10, and n is integer. Page 140. Some power of 10, when multiplied with any number, will change unit of that number, and they're frequently used in actual works are as follows. 10 to the 9 power is called giga, symbol G. 10 to the 6 power is called mega, symbol M. 10 to the 3rd power is called kilo, symbol K. 10 to the negative 2 power is called centi, symbol C. 10 to the negative 3rd power is called milli, symbol M. 10 to the negative 6 power is called micro, symbol micro. 10 to the negative 9 power is called nano, symbol N. Example. Find the following values. Solution. Electric current 0.2 megaamperes equals 0.2 times 10 to the 6th power amperes equals 200,000 amperes. 2. Distances 1,560 kilometers equals 1,560 times 10 to the 3rd power meters equals 1,560,000 meters. Vocabulary. Exponentiation, exponent, raise, surd, principle, regarding, fraction, reciprocal, frequently approximate.